To the third edition of Blissology Talks. I'm Eoin Finn here in Santa Cruz, California, and we're here today with Dr. Lawrence Cheng up in Vancouver. Lawrence is a really good friend of mine and an amazingly inspirational doctor. He runs Connect Health up in Vancouver, which is both a uh, Eastern and Western modality practice. And Lawrence and I run a course called Yoga and Mind Body Medicine, which we're really excited to unroll. So he's Harvard trained, has worked a lot with Dr. Andrew Weil, and just super stoked. We always have amazing chats. And again, the whole goal of this program is I just have so many great people in my life that I end up having juice or coffee and talking shop with. And I thought to myself, why would I not want to share these great people with the world? So Lawrence, so stoked to have you, brother.
Thank you, Eoin. It's another pleasure and honor to be on the Blissology Talks. Yes, excited.
Sweet, awesome. So in our last talk, if you haven't seen this, we actually Lawrence was on my inaugural show, and we had a nice general talk about yoga and healing. And today I thought we'd kind of drill down a little bit more so people can really understand the tools for stress reduction through yoga and exactly what stress does on both our nervous system and our endocrine system. So I thought we could basically start right at ground zero. I thought a great place to start in with this educational talk is, Lawrence, can you tell us a little bit about we'll start off with maybe the difference and then get into the similarities between the nervous system and the endocrine system, how they function.
Okay, yeah, that's a great place to start. So the first thing to know is that in some ways, there's actually no difference between what we talk about, like the nervous system, when we usually think about sort of the brain, the nerves, all the cabling, all the wiring, we kind of call that the traditional nervous system. Mm-hmm. And then the endocrine system, we talk about the different glands, right? So we think about thyroid gland, adrenal glands, but really they're actually all part of the nervous system. So if you think about it, what's the goal of the nervous system? What's the purpose of the nervous system? The nervous system is to sense what's going on in the environment, right? It's got to take input. It's got to sense what's going on in the environment. And then it needs to basically have a response, right? It needs to have the right appropriate response. So that's the goal of the nervous system. Sense from the environment, get the inputs, and then translate it to appropriate action, right? So that's the main goal for the nervous system. So the nervous system does it in two ways, or the body does it in two different ways. One is kind of through what we call the traditional nervous system. So that's brain, spinal cord, all the nerves, and that allows for very quick response, right? So if you get cut or you get burned or something, you have this immediate response.
Or someone throws something at you.
Exactly, right? So that's immediate response, and that is largely sensed and affected by this traditional nervous system. But the whole endocrine system, the glandular system, is still very much part of the nervous system. And we actually call it a whole axis. And this axis starts with the hypothalamus in the brain, and then the pituitary gland, and includes all the glands. So definitely thyroid, thymus, adrenal glands, our sex glands, but a lot more. Actually, the heart is actually also another endocrine gland. So these are all connected through this
glandular system. HPG axis or
Sorry?
Would that be the HPG axis or?
Exactly, yeah. HPG or HPTTAG, whatever you want to call it. But right. I mean, they're all linked. And so through that system, it releases these molecules called hormones, and they go to every part of the body. They provide information to every cell in the body. So the endocrine system has very powerful and broad-ranging effects, but it works slower than, say, the cables and the wires from the nervous system. So that's kind of the two distinctions, but they're actually the same. They're all a sensing and response system, right?
Great. Yeah, I heard a great analogy. There's another show I love watching, Bozeman Science, and the guy's name is Dr. Anderson. He talks about how almost the nervous system is like Gmail, where it's like I'm sending a message to you, and the endocrine system is kind of almost more like Facebook, where just these chemicals go out of your body, and maybe people pick up your feed, or maybe they don't. You know, it's just not quite as specific, the messaging. But I don't know if that's a kind of cool analogy, huh?
Yeah.
Great. So I wanted to get down so now people understand a little bit of the difference of how the nervous system works and how the similarities work between the nervous system and the endocrine system. Like, to look at one of the big things that I think we would all agree on is really plaguing our society, which is the stress response, and specifically, the adrenal function. So maybe let's talk about where the adrenals are, and anything you want to say to introduce people to the adrenals, Lawrence? Okay, we're losing Lawrence here. Hang on. He'll be back any second.
Hi, Ian.
Yep.
Sorry.
Yeah. Okay, it's good. No, you know what? In times like this, we lost you, but it's all good because here we are talking about stress. And technology, does its thing, and it's a real test of like, can I use my yogic tools to not go into my stress response, or can we and just be calm, even though we know millions are watching it? But here we go. So I don't know if you heard the question, Lawrence, but I was asking if you wanted to just explain about the adrenal glands, both the location and their functions. If you can talk about a little bit too, what's good about the adrenal glands when they're in function, when they're in balance, and when they get out of balance, because they kind of get a bad rap, but there's good things that happen in the adrenal glands also. So maybe.
For sure. So the adrenal glands, they're extremely powerful glands. They're tiny little glands that actually sit on top of your kidneys. Tiny little glands. It's divided anatomically into a cortex and a medulla, so kind of the outside part and an inside part. And they produce some of the most powerful hormones that the body produces. Cortisol is one of the main ones, but it makes some of the other, what they call catecholamines. So it makes adrenaline or epinephrine, some of the other related, what they call catecholamines. It also has other hormones that help regulate blood pressure, the amount of water in the body, very, very key important hormones. Now, the thing about the adrenal glands or anything part of the body, it's not that they're good or bad. It's about what the appropriate response is, right? So, right. Yeah, cortisol is not good or bad. Cortisol is absolutely essential for functioning. If you have too little cortisol, you feel weak, dizzy, lightheaded, your blood pressure is low. And we know some people who have, for some reason, we had to take out their adrenal glands, or they have a disease called Addison's where they just can't produce enough cortisol, and it's not compatible with life. You can't function with it. So you need to have cortisol and all these hormones, but if you're in a stress response that goes on and on and on, so we're talking more about this chronic stress that makes this kind of prolonged low level of cortisol, that's when it causes problems. So it's, if it's an appropriate response, cortisol gets released, adrenaline gets released, it's appropriate because we need to respond. We need this, flight response. But if it gets triggered on and on and on in a chronic way for weeks and weeks and months, that's when things start to break down and go out of balance. So it's all a matter of
how
balance.
many, like what, I don't know if it's hard, it's probably hard to say in terms of percentage, but how often are you seeing this chronic adrenal function in your clinic?
I would say adrenal function, or what we call adrenal dysfunction, or imbalance. It's one of the major things we see at this clinic. And I would say in general, I think it's basically an epidemic of adrenal stress in our modern societies. Our adrenals are very much out of balance, I think, for many of us.
Yeah. And just to know where we're going with this in the yogic model for the yogis listening, is that this is our third chakra energy, say the yogis. This is the competitive drive, the ego drive, the fire, this is you against the world, is what yogis told us. The psychology of this area is long before they ever had dissection or any idea what I don't think the glands did from a scientific point of view for measuring the hormones, but just by feeling what was there, that's what they came up with. And if you take the guna system, this is what I think is called rajasic, frenetic energy, that the yogis also left us as an amazing model also. So there is a great yoga map that fits with this, which we're going to explore more, but I just want to relate it back to yoga. So now we're going to hit a bit more technically again. So here's what Lawrence was just talking about, how he sees this chronic epidemic of adrenal alert. And I want to talk to him a little bit about how this affects the thymus gland, which is our immune function. So maybe I'll just leave that with you about what an adrenal imbalance or stress imbalance can do to our immunity. Lawrence?
Yeah, great question, Ian. So anyway, the prolonged effects of stress, or a triggered stress response, causes usually a lot more cortisol getting released. You have to think about cortisol or adrenal stress. It's in emergency mode. It's like the body's switched into this emergency mode. And what happens is, initially with stress, your immune system function actually improves, right? It makes sense because maybe you need to mobilize your defenses, right? So at first immune system improves, but after a while, the immune system actually goes down, the function goes down. So you're much more likely to get sick with an infection of some kind. And there's tremendous amount of studies now. It's pretty clear, pretty amazing studies. They've looked at, say, university students during exam times, and we all remember those times,
Yeah.
versus, say, when you're on March break. And these poor students, they'll do anything for $25. And what they did was they basically gave them a nasal spray with rhinovirus, which is the most common common cold virus.
Right.
And they wanted to see these same students, like how many got sick when they were, say, during exam times versus when they were on holidays. And they found that during exam times, they were 3 times more likely to get sick. Right. So same person, same biology, same physiology. It's just that when they were under stress, your immune system just couldn't work.
Right.
Yeah, so it definitely impairs your immune system. Your ability to fight infection goes down.
Yeah. So tell us exactly how the immune system does fight infection.
Yeah, so to put it simply, there's 2 ways the immune system fights infection. The first one is kind of this immediate response, and we call this innate immunity. So you get an infection, say your hand gets infected or you get a cold, the body sort of gets these white blood cells called macrophages, and they sort of spring into action and they start releasing these chemicals. You get some inflammation, right? Often you get mucus production, or you get some redness and swelling, and that's your body's immune system starting to work, attacking, say, a virus or bacteria, whatever. So that's the immediate response. It's called innate immunity. The second arm of the immune system is called adaptive immunity. And this one's fascinating. This is where, for example, say you get a virus like chickenpox, is that the immune system begins to learn about this new virus and forms an antibody against this virus, or one of the proteins of this virus. And the thymus gland is where these cells, these B cells, get programmed. So they identify the chickenpox virus, and then they make this antibody against it that neutralizes it. And they get all
sci-fi war scene, kind of battle scene, no?
Oh yeah, exactly. So the thymus, we call it the thymus university, because these B cells get programmed. It says, okay, here's the antibody against the chickenpox virus. They get programmed in the thymus, and then they get released, and then they go and neutralize these viruses. Now, the crazy thing about these B cells is there's some called memory B cells. So anytime you've gotten an infection, your thymus gland, your immune system, remembers all these different infections. So every infection you've ever gotten, Ian, there's a whole library, whole store of these B cell memory cells that have antibodies against any infection you've ever encountered. So that's why if you get sick again with the same virus, your body can neutralize it very quickly.
Right, but the first time.
Yeah. Now here's the other fascinating thing that you're finding out, is that they're finding that in the thymus, they've found all these antibody shapes against potential diseases and viruses that we actually haven't even encountered yet. It's like there's building blocks. It's like Lego blocks of antibodies in the thymus gland and immune system that are prepared for some future threat. And it's like, okay, we're going to make these different shapes that potentially might be useful, and we can assemble them very, very quickly.
Wow. So that's incredible to think of the body's intelligence. I mean, we all talk about how the body has so much intelligence, but to actually, what you're saying is that the body is making up immunity for diseases that haven't even come into existence yet. It's kind of making blueprints for something that's not in existence. That is incredible, incredible intelligence. It's hard to believe, really.
Ian, are you there? Sorry.
Yeah, I'm there. Yeah, you cut out for a second, but that's I was just saying that's incredible that the body actually can make these blueprints for diseases that haven't even come into existence. That's incredible intelligence.
Yeah, and I would just add to that, Ian, I think that the theme here is, you know, you want to be in this relaxed state of balance to allow your whole system, your immune system, your neuroendocrine system, to be sensitive to the environment.
Mm-hmm.
When you're sensitive to the environment, the body can take the right information and integrate it and then respond appropriately. But if we're not sensitive, we're imbalanced, we don't read the right signals, right? Then our immune system can't read the right signals. And then if the immune system is imbalanced, it either is not, it's under functioning and you get sick, or the other side of it is it's over functioning, it's overreactive. An overreactive immune system that's not able to discriminate what is a true threat from not a real threat. You get allergies, right?
Right.
And you get autoimmune conditions. Like why should you say react to a banana? Banana's not going to kill you, but if your immune system is overly hyperactive or not balanced, it's going to start attacking things that actually potentially could be nourishing for you. Right. So that's the fascinating thing about the immune system. And then if you take that one step further, is that if the immune system starts to attack its own tissues by accident, starts destroying your thyroid gland, you get thyroid, you know, what they call Hashimoto's hypothyroidism. You start getting rheumatoid arthritis, where your own immune system is attacking the cartilage in your joints. or inflammatory bowel conditions where it starts attacking the lining of your gut. And, you know, I think the other thing for people to know is that autoimmune conditions and allergies, it is increasing worldwide, increasing.
Do you have any specific data, like let's say as opposed to 50 years ago or something?
Yeah, I can't quote you exact numbers, but it's much more, there's much more prevalence of asthma, allergies, multiple sclerosis, rheumatoid arthritis, all these autoimmune conditions. There's a lot more.
Yeah.
And, you know, stress, I think, is a big part of it.
Where I'd love to go with this now is, okay, so that's incredible how, you know, trying to keep your, not have this fight or flight reaction to life is so important for our immunity. We all know it, but to really get deep into how this happens, to me, it's amazing. So thanks for sharing. But I want to bring up another topic, and that is caffeine use. Because caffeine basically stimulates the stress response, no? And it just seems to be so socially acceptable. And I just wanted to ask you what your thoughts were on caffeine use as a, you know, as does it mimic adrenaline? Um, is it you know, how it can upset our our balance, our misreading of the environment as you're describing it?
Yeah, great question. Yeah, I mean, Vancouver, yeah, there's a coffee shop in every block, right? And you
And
see,
I have to say that too, because as a yogi, you know, every year people will give up gluten, people will give up meat, people will give up cheese, people will give up wine, no problem. But the last thing even yogis want to give up is caffeine. It's kind of amazing.
yeah, exactly. Okay, so going down to basics, so caffeine is a stimulant. It actually is very, very similar to, say, adrenaline or epinephrine. It's the same category of these type of stimulants. So yeah, so what does caffeine do? I mean, it causes heart rate to go faster. It causes your blood vessels to constrict. It provides mental alertness. So it does mimic, in a lot of ways, this stress response, right?
Mm-hmm.
Now, is it good or bad? That's the question. People say, well, is it okay or is it not okay? And I guess the answer is complicated because it depends.
Mm-hmm.
People's biochemistry is very, very different. And people's ability to break down caffeine or metabolize caffeine is very different. So some people break it down very quickly and it doesn't cause a lot of negative effects. And
Whichever listening is like, oh, I have that great biochemistry, I can drink coffee.
exactly. Other people, they're slow metabolizers and they can't break it down and they're much more sensitive, right? There's some people who can just throw back, you know, 3 shots and nothing happens, where someone else is, they're getting jittery and nervous. So again, I think with everything, you have to listen to your body. So what do you get? Do you feel anxious? Do you have an increased heart rate? All these things, it means your body's very sensitive to caffeine and you are triggering this stress response. And our advice would be, if you're very sensitive to caffeine, you're actually triggering this stress response, which is actually constriction, right? If you don't have as much negative effects, maybe it's okay, but you do need to really be careful. And I always recommend people to at least go on a caffeine holiday and do cleanses to just see what happens, because you don't know until you take it out of your system.
True.
And sometimes people with even baseline anxiety, when they take caffeine out, their sleep improves and they go down to a more relaxed state.
Yeah.
So I think like everything.
I listened to a Dr. Godfrey's her name. She talks at the Wanderlust circuit I teach on, and she was, I mean, because I feel like we're kind of on this cultural speedball where so many people have coffee in the morning and red wine at night to kind of calm their nervous system. But she was actually saying that wine does actually increase adrenaline, and I was surprised to find that out. But when I start to think about it, when I have red wine at nighttime, I sometimes feel sleepy. I want to go to sleep, but then I usually wake up at 2 or 3 in the morning. I got to pee. I have like very active dreams. I don't know. Is that true?
Yeah, that's true. I mean, alcohol initially has some stimulating effects, right? So your
Yeah.
heart rate can go faster and all this stuff. So it has a stimulant effect, and then typically it also has a depressant effect. So it's kind of got mixed effects, but it definitely affects sleep. There's no
Right.
doubt that it changes people's sleep pattern, and usually you don't sleep as well with
Yeah.
alcohol.
That's interesting. Yeah. So I mean, it's funny, which means you probably need more coffee in the morning to get you going because you didn't sleep as well. And in yogic terms, bringing it back to the gunas, that means we go from the rajasic, frenetic energy to the tamasic, dull, disconnected energy. And the great thing about yoga is it offers the third model called sattva, Sattva, which is calm, balanced energy, which is, I think we were talking about being in this state of relaxed alertness in life. And kind of brings up my next question of how maybe breathing, if you want to address that, I mean, we all know, okay, take a big breath, doesn't matter, cavemen, after they're being chased by a saber-toothed tiger, one caveman, I'm sure turned to the other caveman and said, take a big breath, Zorg.
Yeah.
But, we know this works, the breath, on our nervous system state. But you want to say a little bit about how?
Yeah, so breathing, and the yogis got this right, thousands of years ago, is the breath is the key to our autonomic nervous system. So
Hmm.
the autonomic nervous system's the system that kind of controls what we think is automatic function. So breathing, heart rate, blood pressure, digestive function, things we don't consciously generally have control over. But the breath is very tied to this control of autonomic nervous system, right? So the two sides of it is the sympathetic side, which is, the flight or fright side,
Yeah.
and the parasympathetic, which is opposite, which is the relaxation response. When you breathe slowly and you take full breaths and you inhale and you slow down the breath, it directly affects this autonomic nervous system. And it basically shifts your body into a more parasympathetic or relaxed state. And it does that in a matter of seconds.
Right.
There's a great technology called heart math, which some of you guys might have heard about, and it
Yeah,
measures the heart
right
rate
here in Santa
variability.
Cruz.
Yeah, and we'll talk about it at the workshop for sure, and I'll bring some devices down. But you can see that within seconds of doing deep breathing, that your heart rate variability starts to change. It's that quick.
Right.
Well, it's shifting your parasympathetic. It's shifting to a parasympathetic relaxation response, the breath work.
Yeah.
But it's very quick, and
Oh, we got Lawrence frozen there for a second on that note. Um, Talk about flight, fright, or freeze response that's happening on his screen. But while he's frozen, I wanted to bring up another topic too of how oxytocin also helps. So hopefully Lawrence can hear me as I'm bringing this up. But so we're talking how the breath can help to control the nervous system, how it helps to slow us down. But when Lawrence comes back, I'd love to have a quick last topic.
no, sorry, I lost you there for a second.
Yeah, I lost you there. But I was just bringing up a question while you're frozen. I was saying it's funny. It's a flight, fight, or freeze response. It was happening on your screen. Anyhow, shifting from the nervous system and how breath can control the nervous system, I just want to bring up one last topic, and that is, maybe not something that people traditionally think of as a yogic technique, but if you're in the field, you realize that it is all about love and connection. And every yoga class I've ever taught since the very first day I ever did, we start with hugs. And I guess my specific last question is about the effect of oxytocin on the adrenals and stress response in general. Uh, and maybe we'll open up to not just oxytocin, but all chemicals of love in general.
Chemicals of love. I like
Yeah.
that. Well, Candace Pert, if you haven't read The Molecules of Emotion, it's an amazing book where Candace Pert talks about how these different molecules, oxytocin being one of them, really when they're released from the brain. So if you have this feeling of love or compassion, or you're hugging someone, or you're generating this feeling, these molecules get released from your brain.
Mm-hmm.
Brain and heart, actually all different glands, and then they flood your entire body.
Right.
And then, you know, many cells, and this is what we didn't realize, is say your white blood cells, they have receptors. They actually
Mm-hmm.
have receptors for oxytocin. They've got receptors for all these different molecules of emotion. So your emotional state is actually translated to every cell in your body.
It's
So
amazing that the chemicals of love, as we're calling them, are actually, you know, hardwired into. We actually have receptors for this. So, you know, we talk about how love heals, um, and you know, it's amazing to see this chemically.
yeah, and you know, we feel this, but now we're finding the science around it. But every cell has these receptors. So your mind-body state, how you're feeling, your emotional state, does affect actually all your cells in your body. Oxytocin is a fascinating neurotransmitter. It's produced in the brain and the heart, and it has one of its effects actually is it reduces inflammation in the body. It
Mm-hmm.
counteracts inflammation. And inflammation looks like it's the root cause of a lot of diseases, chronic inflammation.
Mm-hmm.
It also, what we call, neutralizes free radicals,
Right.
which if you have a lot of stress, it creates this, what we call oxidative stress. And
Mm-hmm.
oxytocin actually neutralizes a lot of this oxidative stress. And it dilates blood vessels, you know, it decreases blood pressure. And so, yeah, these molecules of emotion translate into real physiological effects. That's why it's so important to do these things, these practices, and have these feelings of love and compassion. They're translated biochemically and energetically in ways that we're just beginning to understand.
Wow, that's amazing. Um, so hug someone. Hug someone.
So, yeah.
And actually, one thing that Dr. Sarah Godfrey brought up in her talk was that if you do hug someone, that I don't know if you know this, but she was saying her research says that if you hug a man, you have to hug them 8 times as long because it takes us 8 times the amount of time as a woman to raise our oxytocin levels. So just a little tip out there: hug the men for longer and do it every day. I mean, 8 hugs a day is what we need. So it is good medicine. It is good chemistry. So is yoga, and so is breathing. So I'm so excited to keep collaborating with Lawrence more on our yoga and mind body medicine modules. And I'm really excited about the time we're at in history where we're kind of making a big turn and not just viewing the human body as a machine, but as an intimately interconnected organism. And we need to have so many different systems in balance. And we can't just replace parts. We need to really look at the whole. And the yoga knowledge is so beautiful to bring into this field. So we're really excited to bring it all to you whenever you can sign up for the course. But if you can't, hopefully this podcast has been super informative for you. Keep spreading the good vibes. Lawrence, I want to thank you for all the amazing work you do.
Thank you, Ian. I just want to add one thing, which I think is so key, is that it's the practice of these things. It's developing a daily practice. It's the consistency of hugging, of breathing, of doing yoga. Because as we do it more and more, we pattern the wiring in our body, in our system, and it becomes more and more available to us. So practice is the key. Our
Nice.
bodies get more and more primed to it.
So make really good habits.
Yeah, exactly.
All right. So big smiles. I'm smiling right now. It's so good. I feel amazing after this talk. Thanks for sharing all your knowledge. Be kind to everyone out there. Just start a habit of kindness because kindness equals happiness. period. I'm Ian Finn. This has been the third edition of Blissology Talks here in Santa Cruz. Namaste, everybody, and
Namaste.
aloha.